Hello everyone. Today we are going to see about Z transform problems. The question is determine Z transform and ROC, that is region of convergence of the signal x of n is equal to a power n into u of n. Solution. We know that the unit step signal is represented by u of n, which is equal to 1 for n greater than or equal to 0, and it is 0 for n less than 0. Okay, so this is the graphical representation of u of n. Here x-axis is n and y-axis is u of n. So if you see in the x-axis, this is n is equal to 0 and this is n is equal to 1, n is equal to 2 and n is equal to 3 till n is equal to infinity. The value of u of n is equal to 1. Okay, for n less than 0, that is for minus 1, minus 2, minus 3, till it is minus infinity, u of n is equal to 0. So for unit step signal, u of n is equal to 1 for n greater than or equal to 0 and it is 0 for n less than 0. And from the definition of Z transform, x of Z can be represented as Z transform of x of n, which is equal to summation n varies from minus infinity to infinity, x of n into Z power minus n. Since x of n, that is the given problem is x of n is equal to a power n into u of n, and this u of n is equal to 1 for n greater than or equal to 0, the limit can be changed as, okay, capital X of Z is equal to summation n varies from minus infinity to minus 1. See, listen, here I have split this summation n varies from minus infinity to infinity into two limits. Okay, one is the summation n varies from minus infinity to minus 1, x of n into Z power minus n, plus summation n varies from 0 to infinity, x of n into Z power minus n. Now substitute x of n's value. Okay, what is x of n? It is a power n into u of n. Okay, so summation n varies from minus infinity to infinity, a power n into u of n into Z power minus n, plus summation n varies from 0 to infinity, a power n into u of n into Z power minus n. So we know that from, see, listen here, I have mentioned infinity. It is not infinity. Actually, this is minus infinity to minus 1. Please make a note of it. Summation n varies from minus infinity to minus 1. Okay, so for minus infinity to minus 1, the value of u of n is equal to 0. So the entire term goes 0. So the remaining is summation n varies from 0 to infinity, a power n into u of n into Z power minus n. Okay, so the first term becomes 0. So listen, this is the limit. Summation n varies from minus infinity to minus 1. So here I have wrongly given. It is not infinity. This is minus 1. So that's why your u of n is equal to 0. So the first term goes 0. The second term is summation n varies from 0 to infinity, a power n into, and u of n is equal to 1 for n greater than or equal to 0. That is from n is equal to 0 to infinity, u of n is equal to 1. So that's why I have substituted u of n is equal to 1 Z bar minus n. Okay. Now, x of Z is equal to summation n varies from 0 to infinity, a power n Z bar minus n. Summation n varies from 0 to infinity. So listen, I have taken this n outside, that is power n outside. So here I will be getting a and here I am getting Z bar minus 1. So a into Z bar minus 1 the whole power n. So listen, a power n will give you a power n, and Z inverse power n means the power has to be multiplied, that is minus 1 into n. So you will be getting Z bar minus n. Okay. Now substitute n value. So n varies from 0 to infinity. So substitute n value from 0 to infinity. So first is a Z inverse the whole power 0. So substitute n is equal to 0. So since you are having summation, put addition symbol, and a Z power minus 1 the whole power 1 plus a Z power Z inverse the whole square plus a Z inverse the whole cube, plus it goes till your n is equal to infinity. So we know that we have the infinite series formula that 1 plus r square plus r cube plus infinity will give you 1 by 1 minus r, where the modulus r should be less than 1. So this is the condition for the infinite series formula. And we know that this anything past 0 is 1. That is meaning this term, see here, this term is, it becomes 1. Okay, now you are comparing this equation number 1 and 2. So here I am getting 1 plus a z inverse power 1 plus a z inverse power 2 plus a z inverse power 3, etc. So here I am getting the infinite series formula 1 plus r square plus r cube plus etc. till infinity. The formula is 1 by 1 minus r. So when you compare this equation number 1 and 2, we can conclude that this r term is equal to a z inverse. Okay, the r term should be equal to a z inverse, and here wherever you have r, you have to substitute a z inverse. Okay, now hence x of z becomes 1 by, okay, that is, listen, just a minute. X of z becomes 1 by r. So here substitute r is equal to a z inverse. So x of z is equal to 1 by 1 minus a z inverse for a z inverse less than 1. So here I have expanded this 1 by 1 minus z inverse can be written as 1 by z. So a by z for a z inverse less than 1. So when you take the LCM is z. So 1 by, so here you will be getting one more step, that is 1 divided by z minus a divided by z. Okay. And in the next step, this z goes to the numerator. So I'll be getting x of z is equal to z by z minus a for mod z inverse less than 1. Okay, so this is your x of z. And now we need to find the ROC, that is the region of convergence. Now, ROC. So the given ROC is mod a z inverse less than 1. So z inverse can be written as 1 by z, that is a by z. That is mod a by z is less than 1, or mod a is less than z. So here in the left hand side, the z is in the denominator. So when it goes to the right hand side, it goes to the numerator. So mod a is less than mod z, or we can say the mod z is greater than a. Okay, and this is the pictorial representation. So here you will be having the real term of z and the imaginary term of z, and this is the z plane. So here I'm having a. So take a as the radius. So you'll be getting one circle. Okay. So ROC is mod z greater than a. So meaning that my ROC, the region of convergence, is the entire z plane which is outside the circle whose radius of a. Okay. So this is the conclusion. ROC is the entire z plane outside the circle of radius mod a. Thank you so much for watching this video. Thank you.